The late nights, the hard times, the hard grind, it's all worth the chance. The sacrifice, the deadly fights, I survived, it's all worth it, yeah. I've got more hunger, I just wanted more. This is my dream, I've gotta go for it. I've got high standards, I demand more. Why aim for something small when you can go for it all? I have to be 1% of the 1%. Yeah, I give my all every day till there's nothing left. Oh, I can make it through the hard times. I've got what it takes to be a champion. I won't lose composure when it's game time. I am meant to be a champion. I have to be first across the finish line. I must be the champion. No, nothing can stop me, this is my time. I am a champion. I am a champion. Discipline, dedication, determination, it's all worth the chance. My super drive, my heart of fire, my desire, it's all worth the chance. I work harder, I work smarter, I aim higher. Whoa.
Hello students, you are welcome to chemistry. My name is Bajis, and on this platform, Bajis Tutor, you are going to be learning a lot of ways of tackling wire problems without much difficulty. Today, we are going to talk about how to identify the period, the group, the blocks of an element just from the electronic configuration. I know most of you are familiar with how to write the electronic configuration. So we are going to be applying that to identify the group, the block, and the period of an element in the periodic table. And we can also, from the electronic configuration, determine the kind of chemical reaction it is likely going to take part in. Now, look at it. We have two atoms of elements of the periodic table are represented as X2311 and 3216. The first question is write the electronic configuration of X and Y. State the group of X and Y, state the block of X and Y, and state the period of X and Y. Let's go. We are going to write the electronic configuration for X, question A, for X 23, 11. You know what 11 stands for? That is the atomic number, the number of protons that are present in the nucleus of an atom of that element X. So, we move. If we are having problems with writing the electronic configuration, you might find this one difficult to write. I will advise you to go to your textbook. First of all, look at how to write the electronic configuration, and then you'll be able to apply them to get all these group, period, and blocks of the elements. This one goes 1s2, 2s2, 2p6, and this 10. What we are having here stands for the electrons. 2 electrons going into the first shell, that is 1s. Then the second shell, both 2s2 and 2p2 are combined to give you the second shell. Now we are left with just one electron, which goes into 3s1. Remember how electrons are filled from this 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, and 4f. The electron goes into the first shell, shell 2, s orbital field first, p, and it goes that way. So if you have learned it, you'll be able to write the electronic configuration properly. Then for x, let's check how many principal quantum number do we have. Principal quantum number 1, that's k shell, both of them. For L shell, that's principal quantum number 2 and principal quantum number 3. So these 2s2, 2p2 belong to the same main shell. Now, how do we identify? The first question is, if you find you are writing the electronic configuration for x, how do we get the group of x? The group of x, let's take this one as A1. The group, let's look at the last main shell. The last main shell, shell number 1, shell number 2, shell number 3. Then this last shell, just count the number of electrons, or look at the number of electrons you have. We have just one. It means the element x belongs to group of x is 1, group 1. The group of, it is written in Roman figure 1. Then, what is, we are now going to look for, what is it again? For that same x, we are going to be looking at the block. Let's look at, when we are filling the electrons were first filled into the 1s, followed by 2s, 2p, and lastly 3s. So where the last electron, the orbital, the last electron entered into, that is 3s, gives you the what? It gives you the block of that element. Therefore, block of x is s. It remains the period. The period gives us the number of main shells that are present. The number of main shells, that is the principal quantum number. Now we have 1, 2, and 3. That gives us the period of x is 1, 2, I told you earlier, 2s and 2p, they belong to the same principal quantum number 2. So it means that we are having 1, 2, 3. We are having 3 shells, and that gives us period. Period 3. Now let's look for what state the period of x and y, state the block of x and y, state the group of x and y. We have stated all those ones for x. For y, we have, where is it? y 32, y 32 and 16, meaning that the atomic number is 16, that's 16 protons and 16 electrons, since it's not carrying any charge. So we have 1s2, 2s2, 2p6, I'm counting, that's 10 electrons, then 3s2, we are left with 4, and 3p4. 2 plus 2 plus 6 plus 2 plus 4 gives me 16. The atomic number, which is the number of electrons in a neutral atom. Now let's quickly state the group. Group of y is the group. Let's just check the last shell shell, second main shell, and the third main shell. So this is the last shell in this element. Let's calculate the total number of electrons present in the last shell. 2, that's the last shell, 3 in the same main shell. 2 plus 4, which gives me 6, is 2 plus 4, which is equals to 6. Then, the next one is the block. Yes, I believe you should be able to tell me what the next block is. Oh, you are correct. It belongs to block P. Block P, because the last electrons enter into P orbital. While we were filling the electrons, we ended up filling the remaining 4 electrons into the 3 P orbitals. So the block is P. P block. Then, how about the period? Period of Y is, what is it? You are right. You are right. That is period 1, 2, 3. And so, these have already answered the whole questions. And I'm very sure if you're able to put it down this way, during the exam, you are going to get the maximum mark. Now, this is an assignment for you. An element is represented as an element, or let's put an atom of an element is represented as assignment as X 27 30 state, states the group period and the block of the element. So, that is an assignment for you. In our next class, we are going to be looking at other different questions where we are going to ask to determine the type of chemical reaction the elements will likely undergo from the electronic configurations. Thank you for watching. Have a nice time until we meet another day. Remember, the assignment must be done and be shown. Goodbye. Have a nice time.